Hello, we try to solve this question, one of the problems from your exercise, Introduction to Forces worksheet. So this is question 1. Two forces act on a point. One is 50 newtons eastward and the other is 80 newton north eastward. Calculate the magnitude and nature of the resultant and the equilibrant. So when you start to solve these kind of questions, I really advise you guys to revise the notes provided for you. So I will show you, refer to the notes which we're trying to discuss. For example, if you go to these lecture notes, try to go through them. Introduction to forces and resultants, try to understand the definition for them, and especially related to directions, go to section 2.5, which is on page 7, which will describe with you how can we specify the force with the angle. And as well, I also encourage you guys to go through this sheet and read section 2.8, resultant and equilibrant, and try to define both of them and how can we apply them and how they look like. So we'll go through this example and then we come back to this sheet, so to this lecture notes. So if we go back to this question, the first step, we have two forces. One is 50 newtons east and the other one is 80 newtons. So for very simple, this will explain to you. So if I try to sketch very simply, this is my first force with a value of 50 newtons, and trying to write the values for it at the moment. So let's say this is 50 newtons, and the other force is 80 northeastward. Represent for me that this force will be going in that direction from the same point with a value of 80 newtons and the angle is 45. So this, we put the value 80 newtons, and then the angle represented here will be about 45. So if I put the angle, we'll show you what we want to achieve in this example. Let's use some equation samples so we have the right angle specified in this. So if I try to solve this question, I really need to determine the resultant force for this one. So I'll try to use the method we introduced in the class earlier on Friday, and we'll see how it works. So if I just do this arrow to show you how this works. So for example, I'll start with a force going in that direction, which has the value as we specified earlier, which is the 50 newtons. I'll put the value here, and then because there is a line going in that direction, so I would just connect a line so it will show me exactly the 45 degrees how it's moving. So I have from there about 45 degrees and 80 newtons. So let's just connect these together to make sure. Yeah, and I'll write the value for this force, 80 newtons. I'll put it here so at least it will be very clear for us. And as well, this, if we go back to the definition for the resultant force from the sheet, we can understand exactly what we mean by that. So the resultant here, the definition for it, the resultance of a force system is that single force that can replace the effects of all the forces in the system combined. So it means we represent the 50 and the 80 newtons to our one force which calls the resultant. So if I come back here, I will replace this force starting from the point we started, we going to the end, and that will be called my resultant force. I will give it this color to distinguish between them, and I will give a capital R letter, so it's representing my resultant force. Now we know this angle is 45 from this because it's stating the question is traveling north eastward, and therefore if we write the equation for finding the other angle between this one, between the 50 and the 80 newtons inside, so this equation will represent for me, for example, if I say the total angle is 180 degrees, and as well I'm using the equations edit on PowerPoint, and subtract from it the 45 degrees, that's what results for you 135 degrees, which indicated in that drawing. Therefore I will write that's the angle here between these two forces will represent the 135. So I can just copy this one, Control C. It's not working at the moment. Let's see if we can go around it. So it's okay. So I got it here. We bring this one here and we type 135 and then we add the degree. So that will represent for me the degree. So this between the 50 newtons and 18 newtons, the angle is 135 degrees. Now we try to find as well this angle, which is, we call it alpha, not this one, because that represents this angle is where we started from, the point of the resultants. Again, we want to combine the 50 newtons and 80 newtons with one resultant force. Therefore I will start from this point. So I will call this angle alpha, and because I'm using the PowerPoint, therefore I go to Insert, Equations, and from that point I put alpha. I'll find alpha, and then I'll just place it here to make sure I'm using the right word. Now, from mathematical equations, I need to determine the value of R and the value of alpha. Therefore, I'll write the equations. I'm using the equations editor. Here will be the solution. So first of all, I'll start with the R to the power 2. So R square equal to the 50 square. Well, I need to make sure I'm writing the right equation. So 50 to the power 2 plus 80 to the power 2, which is mean 80 square, minus 2 times 50 times 80 times cosine. Which angle will I take? I'll take the angle which is opposite to R, the resultant force. So that will be 135 degrees. Make sure you write in degrees because you don't want to solve this question in radians. After simplifying this equation, you will determine the value for this answer. So will be equivalent to, so try to solve this one. It's just editing. It takes time when you do it using this editing. So, and then you find that the R value, if you're using your calculator, it will be equal to 120.65 newtons. Please always remember to write the units. Very, very important to have your units. So that's the value of R. Remember, to solve R, you need to take the root square for 50 square plus 80 square minus 2 times 50 times 80 times cosine 135. And now, since we determined the value of R, we need to determine the value of alpha. So using the same principle of mathematics, the sine rule, therefore I need to write a new equation to solve for me the sine rule. And I'll put this one here using again the equations editor, which is really helpful for me. So first of all, sine alpha, and that will represent for me, so if I'm using sine alpha, opposite to sine alpha is the 80 newtons, so I'll write 80 equal to what? Sine 135 degrees, because that what we determined earlier the angle divided by the resultant force, because opposite to this angle is the R, therefore will be the value 120.65 newtons. If you continue with the solution for this, you will end up finding the result for this equal to a value of alpha, if you solve it correctly and no issues, and make sure your calculator is set up to degrees, will be equal to 27.96 degrees. Now, since we stated both of these solutions, the answer for the final answer for the first part of this question is to find the resultant will be stated in this way. So let us write it together. So what you will be saying here, that you need to restate the magnitude for the resultant force we found. So we say 120.65 newtons. So this n represent the units for the force acting. 27.96, make sure to put degrees, and that's just to specify the angle. And now there are two ways to describe that. In the first one, 120.65 newtons acting 27.96 north of east, or you can restate this one in a different way, which I'll write it now for you guys, or you say 120.65 newtons acting east 27.96 degrees north. So these are the two ways on how you describe the angle. I would just split them up to show you the difference between them. So either use this one, the first one, the magnitude, units of that magnitude of the force, of the resultant force, acting 27.96, which is the value of alpha, north of east, because we're going in that direction, or 120.65 newtons acting east 27.96 and north. So that's the two ways. If you forgot that, I really recommend you guys to go to your lecture notes and you go to the section which it's 2.5 directions, page 7. So I'll revise you about this. There are two ways to describe the angles and the resultant force. So please go through this section 2.5 directions and you will see this example very clearly. Now, since we finished the first part of this question, now we can start solving the second part of this question. Second part, we start first a new box so we can answer the second part. B, we want to find the equilibrant. Again, I really advise you guys to go through the lecture notes, section 2.8, page 9. The equilibrant of a force system is that single force that can balance the effects of the force system. The equilibrant of a force system will thus have the same magnitude as the resultants of the system, but it works in the opposite direction, and we'll see that very soon. So how can I answer the equilibrant for this question at the moment? So if we type the magnitude equals to 120.65 newtons, because it's the same value of the resultant force, only it's the opposite direction. Now direction will be 27.96, and make sure, sorry, it just didn't have a space between them. So if I need to add the degrees, then I'm going to the equation editor, and that's very important here, will be south, opposite of the resultant, of west. Now let's see how can we sketch that. If we go in the corner and we have a bar, so this is north and south, and this is, let's say, my east and west. So let's name each one of them so you can remember them. North, and Control C, Control V, so we can do it very, and this is east, Control V, and this is west, Control V, and this, the last one, is south. Alright, so the resultant force, which we determined earlier, was going in that direction. So if we put it carefully, it would be a small angle, as we found it to be 27.96, and the value for it will be equal to 120.65 newtons, the magnitude. We sample this one as R, which is the resultant force. Now, opposite to that will be the equilibrant, which we need to identify it to be going in that direction with a value of, let's give it a green color to distinguish between them, and we give it, so that will be going in that direction. Let's give it the letter E as equivalent, and that will be the magnitude 120 point, I think I got this number, would be 0.65, 120.65 Newton. Direction is 27.96 south of west. So just make sure that I got this wrong at the beginning. It should be 120. So it's just the same magnitude of the resultant, just opposite direction for that. And this is the end of this question. So please, I hope you enjoy this video, and hopefully I will get you another one very soon. Thank you. See ya.